Okay, welcome back. We're going to do another problem here where we are using linear functions. So again, I'm going to read, then draw a picture, write a table or a function or something like that, and solve it, and then check my answer to see if it makes sense and if it answered the question. So those 5 steps we'll do again. Okay, so first off, I'm going to read the problem carefully, and usually reading it involves circling important things about it. So you have $100 to spend, okay, $100 to spend on a barbecue where you want to serve chicken and steak. Chicken costs $1.29 per pound, and steak costs $3.49 per pound. Find a function that relates the amount of chicken and the amount of steak you can buy. Okay. Graph the function. What is the meaning of each intercept in this context? What is the meaning of the slope in this context? Okay. Alright, so we have $100 to spend. Find a function that relates the amount of chicken and the amount of steak you can buy. This is interesting. Okay, so I'm going to have a function, so the amount of steak plus the amount of chicken, right, is going to cost me something less than 100, right? So 100 is kind of like my limit. And if I buy 1 steak plus 1 chicken, it's not equal to 100, right? So I need to modify this function so that, let's see, the price is 1 steak would cost me $3.49. 1 chicken would cost me $1.29. Okay, so if I bought 2 chickens, right? So let's draw a picture. I should have drawn a picture of the first thing. So I have maybe just draw a chicken leg. So chicken legs cost $1.29 per pound. And then steaks right, does that look like a steak? Costs $3.49 per pound. Okay, so if I bought 2, then it would be 2 times $3.49. If I bought 3, it'd be 3 times $3.49. So the cost of a steak is going to be $3.49 times the number of steaks. So I'm going to call S, we'll call the number of steaks. So $3.49 times S would be the cost of the steaks, plus $1.29 per pound. So about 1 pound it'd be $1.29. If about 2 pounds it'd be 2 times $1.29. So same thing, $1.29 times the number of chickens equals 100. So that would be the cost of the steaks plus the cost of the chickens would have to be equal to 100, would be the maximum, right? So it'd have to be less than that. So find a function that relates the two. I think I found one. Okay, so now if I can draw a graph of the function. So we haven't had a lot with these decimals before. So what does it mean? So the intercepts, so we'll call this the steak, I guess. I'll call that the steak, and I'll call this the chicken. And so when C is equal to 0, right, then I have 100 equals 349S. So I can do a little table of values, right? So S and actually I want to do C and S because C is my kind of my X. So when C is 0, S is a, well, let me write it down. So 349S plus 1.29 times 0 equals 100. And when anything times 0 is 0, right? So it goes away. So I get 349S equals 100, and I divide both sides by 349. And I cannot do that in my head, so I am going to grab a calculator. So I do 100 divided by 349. The result is 28.65. So the number of pounds of steak that you could buy is 28.65 if you bought no chicken, right? So this is 28.65. So close that down. So this point right here is 0, 28.65. Alright, now if I were to buy no steaks and only chicken, alright, then I would have 0 steaks. How many chicken would I have? So I can write the equation again, and this time s is equal to 0. So this one goes away, right? S times, or if s is 0, then 0 times 3.49 would be 0. So I get 1.29. C equals 100. Divide both sides by 1.29. So C would equal 100 divided by 1.29, which is 77.52. Okay. So when S is 0, I get 77.52. So I could buy 77.5 or 77.5 pounds of chicken if I bought no steak. Right, so this point is 77.52, 0. So there's my graph, and any point in between would be a linear relationship because they're only to the first power. So I already know that it's not a nonlinear function, it's a linear function. So there would be a straight line between those 2 points. Okay, so let's go back and check to see if I answered the question. Find a function that relates the amount of chicken and the amount of steak you can buy. Yes, I made this function right here. Okay. Graph the function, which I did. Find, or what is the meaning of each intercept in this context? So I guess I need to maybe write an answer. So the intercept, so the S-intercept is the amount of steak I can buy if I buy no chicken. Right, and then the C-intercept is just the reverse of that. I'm not going to write it out, but you know the idea. So the C-intercept is the amount of chicken you can buy if you buy no steak. Okay, use this and any other information represented by the equation or graph to discuss what your options are for the amount of chicken and the amount of steak you can buy for the barbecue. So this is a kind of a reflection. So I could tell you that for a given amount of chicken, I can get so much steak. So all of these points on the line represent different possibilities of the amount of chicken versus and the amount of steak that I can buy for a given $100. So all of these numbers should add up to $100, right? So yeah, so when I put them into the equation, this point, whatever it is, so let's say I bought, I don't know, 50 pounds of chicken, right? Then I could figure out with the equation how much steak I could buy, right? So it's 50, and then I plug it into the equation. So 3.49 S plus 1.29 times the amount of chicken is 50 equals 100. So what is the value of S for in this function? So I multiply that out, times 50. And then I'm going to subtract that number from 100, so I take 100 minus that number, 35.5. So we get 3.49s equals 35.5. Divide both sides by 3.49. So the amount of steak I can buy would be 10.2 basically. So if I bought 50 pounds of chicken, I could buy 10 pounds of steak. Okay, so you might want to try to find some value where you're getting kind of an equal amount of chicken and steak. So you can play with the numbers, so it looks like you could buy, you know, less chicken, but then you're not getting as much food, right? So anyway, those are the things you can do once you have the function. You can start looking at the graph and seeing, you know, kind of what are my options, and that's a good thing if you can figure out a whole bunch of different options for your party. What, you know, do I want to buy, you know, a lot more chicken so people can be fed, you know, or do I want to get more steak? If I have a small party and more people like steak, then I probably will be, you know, up in this region. Okay, now we have some more exercises coming up that are these sorts of tasks. Oops, I forgot to answer the question, what is the meaning of the slope in this context? So the meaning of the slope, so it's going down so much and over so much. It's kind of a difficult question, but it's going to go, for every 1 pound of chicken, it's going to, well, actually the ratio of the steak to the chicken price is really what the slope of the line is. So that for every $3.49 or $3.49 pounds of chicken, it's going to go down 1.29 pounds of steak that you can buy. So maybe you can put in some values and check what 1 pound of chicken gives you, and then see how much it changes, and it should be well, I don't want to go into deep solving of equations here because we're going to get to that a little bit later, but when you solve equation for the s variable, you would subtract that from both sides and you would get minus 1.29c plus 100 would come over to that side, and then you divide everything by 3.49, which I already know this 100 divided by 3.49 is 28.65. So this is the slope of the line. It's negative 1.29 for every 3.49, and that's what the slope of the line would be in this context.